Good morning, Algebra 2 Trig Honor students. So this one is for part 3 of Algebra 2 and Trig Final Review Analysis. So last time we talked about some of the problem from 1 to 42. And now we'll take a look at the other type of problem. Okay, so this one, again, it's all about the mixture of trig problems and Algebra 2. Okay, so for 43 to 46, it's about solving the trigonometric equations with the restricted domain from 0 to 2 pi of theta. Okay, so we'll take a look at that, the complicated one. And so it looks like 43, that one looks kind of a little bit weird. Okay, so let me just snip that one and I'll put it into the new slide. So again, the restricted domain for this one, so we need to find out all the solution for theta from 0 to 2 pi. Okay, so let's put it right here. Okay, so let's start it off with rewriting. We do know that cotangent, cosecant, all those things right there, so they all can be written as in terms of sine and cosine. Okay, so cotangent is written as negative cosine over sine. And then cosecant is written as 1 over sine of theta. Negative root 2, so that's just a coefficient. We just want to carry that over. And cosecant, it's 1 over sine of theta. And then cosecant, 1 over sine of theta. And since we do know that they're all given with the denominator of sine of theta, so basically we can just eliminate the common denominator. Simply multiply the whole thing by sine of theta. Both sides. So we do have negative 2 cosine of theta plus 1. So that equals negative root 2 plus 1. Because once you multiply the least common denominator, so there's no more denominator remain. And now what we can do with the rest of this, we just want to combine the constant terms together. So we got negative 2 cosine of theta. So we just want to isolate that cosine theta term. And then the 1 cancel out. So what's left here on the right hand side is just negative root 2. And then divided by negative 2 on both sides, so we do have cosine of theta. So that equals root 2 over 2. So keep that in mind. This one is just one of those special ratios of cosine of theta. So now let's just do the analysis with the unit circle within all the quadrants. So we do know that all students take calculus. So this one could be in quadrant 1 and also could be in quadrant 4. So the circle looks kind of a little bit weird here. Apologize for that. So root 2 over 2. So this one, if you try to rationalize it, it's 1 over root 2. So we do know that cosine of theta is root 2 over 2 here. And sine of theta here is also root 2 over 2. So that means this angle is what? 45 degrees. So 45 degrees. So in terms of radians, so that means it's what? Pi over 4. And we do know that the reference angle here, it's also pi over 4, because that you're going by with that the terminal side and also the x-axis. So that means the other solution for this one would be considered 7 pi over 4. So pi over 4, 7 pi over 4. Okay, so you're going by counterclockwise. So we got 2 solutions for this. Okay, so now let's see what else that we have on the template. So perform the indicated operations. So for this one, it's all about the structure of compositioning of functions. F of g of x, or g of f of x, or g of h of n, or h of g of n. Okay, so they're quite similar. So let's look at the one down with the little open circle right in between. So number 50. So again, compositioning, so that means you need to plug in the new variable into the function. Okay, so number 50. Again, let me just snip that one. Okay, so for number 50. So we do have g of n. It's a quadratic binomial. And then h of n, it's a linear binomial. So now we need to put it in as g of h of a. So anytime they see the open circle, that means this one is compositioning. So that means you want to put in that h of a into g. So let's start it off with h of a. So start changing the variable. So instead of using n, we're using a. So for h of a, it's written as 2a plus 1. And then for that 2a plus 1, so this one just becomes the new variable for that g of n. So instead of using n, we're using that 2a plus 1. So 2a plus 1 quantity square plus 3. So again, compositioning, replace the new variable, replace the old variable with the new expression. And then for the rest of this, we can expand it out. So expand it, so we do have 4a squared, 2a times 1 times 2, so we do have 4a and 1 squared, so 1. So this one is a perfect square binomial expansion, and then plus 3. So we write it, so we got 4a squared plus 4a, and then plus 4. And for those you might be wondering, do I need to take out the greatest common factor? Not necessarily, so this one is done. Okay, so just boxed it. So it's a quadratic trinomial. Okay, so now going back to the template again. So for the rest of this, 51 to 54. State the number of complex root, the possible number of real imaginary roots, and the possible rational roots, and the interval in which all real root lies for each equation. So this one, interval in which all the real root lies, so this one, just skip that part. And then find all roots. Okay, so let's take a look at that, and let's see, let's do the one that's a little bit difficult. Okay, so now take a look at that, number 52. So state the number of complex roots. So this one, so we do know that n equals 5, so it could be what? So 5 possible roots. And what about the real root? It could be 5 real roots, or it could be 3 real roots, or it could be 1. So by using that, the n minus 2 theorem, so 5, and then 5 minus 2, you got 3, 3 minus 2, you got 1. So for the real roots, so we could end up with 5, 3, or 1. And then what about for the imaginary root? So for the imaginary root, we can get either 4, 2, or nothing. Well, because if that's 5 real root, that means none of those root are imaginary. If 3 real root, that means 2 of those. The other 2 root would be imaginary. And then if that's just 1 real root, that means 4 of those imaginary roots would be the 1 remain. Okay? So now let's find out the actual roots. Again, we're not doing the interval with all real root lie in the equation. Okay, so let's find out all real roots and the imaginary. So what we need to do is that the theorem P over Q. So P is always the possible factor of the constant terms. So we got negative 45. And then Q, it's always the possible factors of the leading coefficient. So it's 1. So you want to find out all the possible factors of negative 45. So we do have plus minus 1, plus minus 3, plus minus 5, plus minus 9, plus minus 15, and then plus minus 45. And then the denominator just all over plus minus 1. So what we need to do next, we need to perform the synthetic division. And then we need to find out which one is going to work. Okay, so the first thing that I want to find out is the characteristic of the number here. So we got 1, negative 5, 10, negative 50, 9, and negative 45. And looks like the majority of the number could be divisible by 5. So you probably want to start doing with 5 first and see whether that's a real root or not. And then once you end up with the even power, you can either factor it or you can continue with the synthetic division with the rest of the possible roots. Okay, so divisor, so let's start it with x equals 5 and see what happened. And then the rest of the coefficient here, so we got 1, negative 5, 10, negative 50, 9, and then negative 45. Again, synthetic division, so the first number, we don't do anything about it, bring it down. So 1 times 5, that's 5. Combine them, so 0. 0 times 5, 0. So then that's 10. 10 times 5, 50. So which is what? 0. 0 times 5, nothing. So 9 plus 0, 9. And then 9 times 5, 45. So eventually the remainder is 0. So what happens if you end up with the remainder, it's non-zero? So that means you have to start it over with some other possible divisor. Again, the reason why that I choose 5, because the majority of the coefficients, and they're all divisible by 5. So things such as 5, 10, 50, 45, the majority of the number in the coefficients, it's all divisible by 5. So that's why I choose 5 first. And then you want to rewrite it. So this one is written as, well, started with x minus 5, because that's the divisor. And then the rest of the quotient. So we do have 1x to the power 4. Again, anytime that you divide it by the divisor, so that means the power, it's always being reduced down by 1. And then the next positions, the x to the third power, so that one is a 0, x to the third power, no need to rewrite it. So then that'll be 10x squared. And then 1x, well, x to the first power, so the coefficient is 0, so there's no need to rewrite that term. So it's 9 plus 9. And then the rest of the, well, this one looks kind of like a quadratic, but it's a fourth power trinomial. And this one is factorable, so once you factor, so it's written as x squared plus 9, and then x squared plus 1. So what I did here, I did it mentally, or you can just come up with the smiley face format. So 9 is just like 9 times 1. And then 9x squared times 9x squared plus 1x squared, so 10x squared. So set that equal to 0, and then we do have 1, 2, 3, 4, 5 solutions. So 1 is real, the one that we found. And then this one here, set that x squared plus 9 equals 0. So you see that x squared equals negative 9. So that means x equals square root of negative 9 plus minus. So it's plus minus 3i, imaginary roots. And also this one could be an imaginary root as well. So x squared plus 1, set that equals 0. So subtract 1 both sides. Square root both sides, so x equals plus minus I. So we got 1 real and 4 imaginary roots. Okay, so now the next type of problem, again, going back to sequences in series, and this one is a geometric sequence. So given the explicit formula of a geometric sequence, find the first 5 terms of the 8 and the 8 terms. So this one is pretty straightforward, so just plug in a number. So it started with n equals 1, so n equals 1, this one turns out to be 1. So that means a1, it's negative 0.8. And we do know the common ratios. It's 5, because according to the structure for the formula, it's a sub 1 times common ratios, and then to the power of n minus 1. So basically just multiply that a sub 1 by 5, and then you got negative, and then a sub 2, negative 0.8 times 5, which is negative 4. And then times 5, so we do have negative 20. Well, actually, it's negative 4 times 5. Yeah, negative 20. And then a sub 3. So keep multiplying that 5. So negative 20 times 5, negative 120. Negative 100, excuse me. And then a sub 4, keep multiplying that 5, so negative 500. And then find the 8th term, so using the formula, 8 terms. So plug in a for n, so negative 0.8 times 5 to the power of a minus 1. So negative 0.8 times 5 to the power of 7. So 5 to the 4th power, then that'll be 25 times 25, 625. And then 5 to the 3rd power, 125. So that's going to be a very small number, negative. Okay, so find out exactly what that is. And also this one, you can convert that to a fractions. So negative 4 over 5, because that's negative 0.8. And then times 625 times 125. So negative 4 times 25, which is negative 100 times 625. So negative 62500, which is what? Negative 62,500 for that number. Okay, so now let's see what else. Evaluate each geometric series described. So you need to find out the sum of this geometric series. So again, the structure given here, this one is written as a sub 1 times the common ratio to the power of n minus 1. And this one we need to summarize, we need to sum up the sum of the first 8 terms. From a sub 1, a sub 2, a sub 3, so on and so forth, all the way to a sub 8. So the way to find out the sum of the geometric series, so the formula for that one, it's considered S sub n equals a sub 1 times 1 minus r to the power of n over 1 minus r. Or this one can be done by using a sub 1 times r to the power of n minus 1 over r minus 1. Well, depending on the value of r, if r it's a fraction, it's easier to use this form. If r it's a whole number, it's easier to apply the alternate form. Okay, so plugging the number, so we do have s sub 8, we're doing number 60. So a sub 1 is 2, and then common ratio is negative 4 to the power of n to the power of 8, and then minus 1 all over common ratio, negative 4 minus 1. So this one is 2 over negative 5, because negative 4 minus 1, that's negative 5, so 2 over negative 5, so just separate the fractions. And then negative 4 to the power of 8, so negative 4 quantity to the power of 8. So negative 4 times negative 4 is 16, so 16. So 4 times, 16 times 16 times 16. So 16 times 16, 256. 256. So you want to find out exactly what that is. So this one, it just helps you to simplify the way through. Quantity square. And then don't forget about that, subtract 1. Okay, so that 1 is going to be a big number. And then after that, you want to multiply by 2 over negative 5. Okay, so that will give you the sum. And now the next one I would like to talk about here is the way to find out the trigonometric expressions. Okay, so this one is dealing with the inverses and also the trig functions. And for those you might be wondering, do I need to use SOHCAHTOA? Yes, you do. But anytime they see the complicated structure with the inverse, with the expressions of the variable, so the first thing, it's better for you to draw the diagram. Okay, so it's better for you to draw the diagram first. So let's take a look at that, 64. So this one, we need to apply the restricted range. The restricted range for inverse of tangent of x is always considered from negative pi over 2 to pi over 2. Again, this one is called the restricted range. So basically what you need to do, so inverse of tangent of x, so this one is showing that the ratio, which is x over 1. Positive, so that means it's in quadrant 1, so x over 1. Opposite over adjacent. Okay, so this one it's written as x over 1. So anytime that I take the inverse of the ratios for any trig function, it's always considered the angle. And for those you might be wondering, do I need to find out exactly what theta is? Well, you don't. So this one can be written as sine of theta. Okay, so again, inverse of tangent of x over 1 is being replaced by theta. And for those you might be wondering, sine of theta, well, isn't that just opposite over hypotenuse? But we don't know the hypotenuse. Well, the hypotenuse, we can just find that in terms of x. So hypotenuse, so this one is given as x squared plus 1 squared. Or x squared plus 1. So using the ratio, sine of theta, opposite over hypotenuse. So this one is written as x over x squared plus 1. And we just convert that from the trig expressions all the way to the algebraic expression. Again, it's just the ratios. So anytime that we take the inverse of trig functions, it's always the angle, but once you find out the sine of the angle or cosine of the angle, or secant, cosecant, tangent, cotangent of the angle, it's always the ratio. So this one eventually is written in terms of x. And that would be the final form. Okay, so now the rest of this, it's all about transformations, making a graph. It's all about the form. So for the absolute value, it's always given as f of x equals a times absolute value of x minus h plus k. So where h and k is the center, and a is just the slope from both sides, positive, negative. So take a look at that, number 66. So the value of h is not given, so that means this one is considered a 0. So the vertex is 0, negative 2. But don't forget about the negative sign right outside the whole function here. So this one is the reflections over the x-axis. So that means the absolute value, the V-shaped curve, it's facing downward. Like that. And also you can always use the slope, plus minus 1 to figure out the slope. Down 1, 1 over to the right. Down 1, 1 over to the left. In order to get more point. And then the next one's the quadratic. So the quadratic form is always written as y equals a times x minus h quantity squared plus k. Okay, so now let's look at that for number 68. So it looks like this one we do have a horizontal compression because the 1/2. But the thing is that the 1/2 we can always simplify it. So this one can be written as negative 1/4 x squared. So take out that negative 1/4. Okay, so this one again. So that turns out to be the horizontal compress. So we do know that h and k is 0, 0. And we do know that's a negative, so that means reflected over the x-axis. So eventually the graph is going to be a little bit wider. In always, you can plug in a number, set up the xy table you want to. So it's going to be facing down this way. And then again, for the cubic curve, similar, so g of x. So this one can be written as negative ax to the power of 8. So for the 8 right here, it's a vertical stretch. So we do know that the parent function of g of x, the cubic function, is always written as a times x minus h quantity to the power of 3 plus k. So h comma k, so 0, 0. So it's supposed to be like a dancing arm curve going this way. But since that's being reflected, so it's going to be reflected over the x-axis. It's a vertical stretch. So it's going to be like this. Okay, let me fix that. So this one is going to be like this. And then the next type, so this one is a rational function. So the rational function that involves with the VA and the HA, the vertical asymptote and the horizontal asymptote. And the structure is always given as a over x minus h plus k, the simple form. So where h is the VA and then k is the horizontal asymptote. So let's look at that, this one here, and the parent graph for the rational, it's always like this. So with the value of 0, so 0, then that would be the x-axis. Well, not the x-axis, the y-axis. So there's a vertical asymptote here. And then plus 2, so horizontal asymptote at 2. So the graph's supposed to be going this way, but due to the negative sign, it's reflected over the x-axis. So everything just being flipped over the x-axis. So it turns out to be like this. Another thing that you can do, you can always find the xy intercept if you want to do that. So xy intercept, set y equals 0, and then you solve for x. And then for the y-intercept, set x equals 0, and then you solve for y. And then the next type of the function here, it's a root functions. So this one's the even root, square root. The parent graph is always like this. It's always like a half sideways parabola. And also the form is always given as a times square root of x minus h plus k. So you might be wondering, so people might be wondering, what about the 2 right next to the quantity? Well, we can always put it out. This one can be written as g of x, so equals root 2 times square root of x plus 3 minus 3. So that means the value of a is root 2, greater than 1, so that means the vertical stretch. And then h is negative 3, and then k, it's negative 3. So negative 3, so that it's in quadrant 3. And then root 2, so that means it's a vertical stretch. So that means the curve is going to be a little bit wider, okay? And also you can set up the xy table to get some point in order to find out exactly what the other points are. So you got to be smart with the positions, the number that you choose. So let's say that x equals 1, because 1 plus 3, that's 4. 4 times 2, that's 8. Then that'd be 2 root 2. So let's make sure that this number can be a perfect square number. So let's say that it's negative 1. So negative 1 plus 3, then that's 2. 2 times 2, 4, root 4, 2. 2 minus 3, negative 1. So negative 1, negative 1. And also get another point. So let's say that this one, let's see, to make it a perfect square number. What about 5? Okay, so x equals 5. So 5 plus 3, 8. 8 times 2, 16. So square root of 16, then that's 4. 4 minus 3, then that's 1. So 5 comma 1. So it's all the way up here. Again, it's a half sideway parabola. Just like that. Okay, so now for the trig function, we actually talked about that before. So, and I'm going to show you that in the next part of the video. The way to analyze that, the ultimate form with the value of a, b, h, k, and also finding the period, and also very important, the one cycle test. Okay, so stay tuned and watch another part of the video that I'm going to put up later. Okay, with all those trig functions graph. And also for the next video, I'll talk about the way to solve for find the half angle, the ratio for the half angle. And also verifying the trig identity, things like that. Okay, so stay tuned. Okay, so any question that you have, so I would like to either fast forward or just rewind the video, go to the part of the problem, especially the one that you always feeling kind of struggle with. Okay, so, and also put in some comment, and very important, make sure that you guys click the like button or the bell, and also subscribe my channel. So I'll see you guys next time. Take care.